Good morning, students. Today we are going to study about the Fleming's left hand rule. So in the last class we are discussing about the Lorentz force here. Okay, how the force which is an acting on the conductor whenever it is kept in a what here, current carrying a conductor whenever it is kept in a what here, the magnetic field. So I already told you that okay, when it is kept in a magnetic field, it will applies the what here, the force. So we have the one rule is termed as an what here, the Fleming's left hand rule. So here is the left hand. Okay, I am stretching this the forefinger and the middle finger and also what is that, a thumb, perpendicular to each other. Okay, I need to find out the what is the direction of the current and what is the magnetic field, and also so how the force which is applied on the water, the conductor. Okay. Now what this particular rule says, so I am just showing like this. Okay, I am right. I am stretching the forefinger, middle finger, and also what is that, thumb in this manner. Okay. Now you just see this. Okay, there is a middle finger is always shows the what here, the current. Okay, please observe here is the current is there, it shows the current. Then the B which is always represents the what, the magnetic field, and this thumb is always shows the what here, the direction of the force applied on the water, the conductor. Okay, so this is how we can have this Fleming's left hand rule. What this rule says, stretch the forefinger, the middle finger and the thumb of your left hand mutually the perpendicular to each other. If the forefinger indicates the direction of the magnetic field and the middle finger indicates the direction of the current and the thumb will indicate the what here, direction of motion of a water, the conductor. So this is termed as an what here, the Fleming's left hand rule. This Fleming's left hand rule is always used in where it will used, just to say this one. Okay, we have a DC motor. What is the meaning there by a DC? A DC is nothing but direct current. We will come to know that what is the meaning of this direct current and all that. Okay. So what is a direct current? So direct current is this motor. So you know motor, there are so many uses are there for this motor. We are using this particular motor in where electric fan, okay, we are using a motor, refrigerators, we are using a motor, the mixture we are using a what here, the motor, and washing machine, so we are using the motor. So here we have how this motor is works. Okay, so here it is. What is the meaning of motor? And motor is a device which converts the electrical energy to what type of energy? The mechanical energy. So you know that the mechanical energy, how to convert the mechanical energy, we already know that from this Fleming's left hand rule. Okay, here the force is applied on it. Whenever the current is passed through this, the force is applied on the what here? Conductor. So therefore this is the current, this electrical energy what we have is converted into what here? Mechanical energy. That is the rule, that is the what we termed as an what here? A motor. What is the principle behind it? The principle is the same as the what we have studied under the what here? The Lorentz force. When a current is carrying a current kept in a water, the magnetic field. So the reason what here? The force is acts on the what here? Conductor. So that is the principle behind it. And what is the rule behind it? The rule is behind this is nothing but a what here? Fleming's left hand rule. So the principle, a motor works with the principle one. When a current is carrying a current kept in a what here? The magnetic field, the force is acts on the what here? The conductor. What is the rule of this? Rule is the Fleming's left hand rule for this motor. So we have the diagram for this. Okay, so you see N and S are the what here? Two permanent magnets. Okay, and here A, B, C, D is termed as an what here? Armature. And R1 and R2 are termed as an what here? Split rings. And B1 and B2 is termed as an what? Split rings. Okay, that is B1 and B2 are termed as an what here? Two brushes. And it is connected to where? To the source. Let us consider the parts of this electric motor. Okay, insulated copper wire, a rectangular copper of wire A, B, C, D. So, this is A, B, C, D. We can call it as an armature. Okay, number of copper turnings are there on this. Okay, number of copper turnings are there on this. So, it behaves as an what here? Armature, or we can call it as an insulated copper wire, a rectangular coil of A, B, C, D. Magnetic poles, a permanent magnets, this is N and S are placed here. Okay, so here some gap is there from here to here. Okay, N and S are the two magnets. There is a split ring is there, so that this entire ring is cut into what here? The two parts like this. So that is why it is called as a split ring. This split ring is used as a what here? Commutator. A commutator is nothing but a what? To change the direction of the current. The positive is becomes a negative, the negative is becomes a positive, like that. Okay, we can change the direction of the what here? The flow of the current. So that is why we are using this what here? The commutator. Axle. So here is these dotted lines, what you are seeing is this is termed as an what here? Axle of that. Okay, and two brushes. It is made up with the copper or made with the what here? This carbon brushes, we will say. Okay, carbon brushes or copper brushes are used. And the source is nothing but a what here? We are using a one source for a current. So this is battery plus and minus like this. So this is what the arrangement of a water motor. Okay, how it works. Okay, so here the working is very simple. Okay, so this entire work is depends on the what? The Fleming's left hand the rule for this. Let us apply the Fleming's left hand rule and then study this particular thing. When the current is passed through this, whenever switched on, it is already on. Okay, when I switch on, current is passed like this and through this B1 brush, and then it is just passed through in this direction. Okay, this is the conductor AB. Okay, whenever it is a flows through the AB, apply the what here? Fleming's left hand rule. Just I am applying this with, I am showing this the fingers. Okay, so like this. Okay, just you apply in this manner. Okay, just you are saying like this. So this is the middle finger, what I am saying. So there is a direction of the current. Mid finger is shows the direction of the current. And this the forefinger is the shows about here the direction of the magnetic field. And what happens to this the force is applied downwards. So please see, here is a downwards application of this arrow mark is the shows downwards. Suddenly this conductor is starts what here? Rotating in this direction, in the opposite manner, it just rotates. Then what happens? The current which is the flows in this direction and then comes back to here. Okay, then there is a couple is acting on it whenever it is moves in this manner. So once again it will spins in another round when a current is passing like this. Once again they apply the same rule. Okay, the Fleming's left hand rule. So it is an opposite direction. So it starts rotating in only one single direction like this. Okay, that's the principle is just you see. When a current is being flows through the what here the X through the brush, let us call it as an this is X, or we can call it as an what here B1. Okay, then AB to what here BC, this to CD. Then the Y brush means here is the B2. B2 is nothing but a what here the brush Y I am saying. Okay, so then into the what here battery. Now applying the Fleming's left hand rule. Just you apply the Fleming's left hand rule, then the current along the AB, it is flows along what here A to B like this. Okay, it is just start flowing like this. The same thing what I had explained here. The motion of the wire is what happens here downwards. In the same manner, it is becomes a what here. So here the motion of the when the current is passed through the CD, then what happens? The motion of this wire is upwards. So, in the same manner, now apply the Fleming left hand rule. The rectangular coil begins to move in an anti-clockwise direction. You please see, here is an anti-clockwise direction. So, in this manner it will start rotating. Anti-clockwise direction. Okay. So, once round it is just in this way. Okay, it starts rotating. In the same manner, so after a half rotation, so whenever it comes like this, so wire CD and the split ring Q, the moves to the left. Wire AB and the split rings, the P, the moves to the right. The brushes X and Y, here is the B1 and also what is that, B2, do not move. Now apply once again the Fleming's right hand rule. Okay, the motion of wire once again it is a spins towards the what here, downwards. Okay, then apply the same rule for the second one. This and this are the same. Okay, then the rotation completely it will start rotating. Okay, so again the coil rotates in a what here, anti-clockwise direction. Okay, even though if you reverse this particular current, the current you just go on reversing it. Okay, this the positive is becomes a negative, negative becomes a positive. By using a what here, the commutator, we can change the direction of the water, the current. So what happens? The reversal of the current in the coil results the continuous rotation of the what here, the coil. The reversal of the current is achieved by the help of what here, commutator. That is nothing but you are using a what here, split rings, commutator rings. So this is the working of what the motor. Okay, motor is works in this manner. So what are the applications of this motor? The application of motor is it is used in what here, electric fans, refrigerator, the mixer, and also grinders, and also washing machine. So there are so many applications are there for this motor. So this is all about the motor. So thank you for watching the videos. Thank you once again.